So we're jumping into another set of molecules that you need to be able to know how to name, and really the naming for these are super simple now that we've got really the basic rules of nomenclature down. So the first group that we talked about were called alkanes, and these were compounds that contained carbon-carbon single bonds. These guys were what we referred to as aliphatic and saturated. Now, some other compounds that we need to talk about, or other families that we need to look at, are what we call alkenes, alkynes, and some cyclo compounds. And these guys are all aliphatic as well, in that they all don't contain benzene. But what you'll notice is that in most of these compounds, they're not saturated. So they don't contain all carbon-carbon single bonds. Somewhere in the molecule, like for example alkenes, contain a carbon-carbon double bond, or alkynes, they contain a carbon-carbon triple bond. And so we have to pay attention to that, and we have to be able to identify what compounds are alkanes, what compounds are alkenes, and what compounds are alkynes. And so these compounds, because they don't contain all carbon-carbon single bonds, they're considered unsaturated. And unsaturated means somewhere in there is a carbon-carbon, either double or triple bond. So if it's a double bond, we consider it an alkene. If it's a triple bond, we consider it an alkyne. You, for the purposes of Chem 30, will never see a compound that contains both a double and a triple. It will either be one or the other. And also you'll only see compounds that contain only one double or one triple. You won't see a compound where you'll have to name a compound that's got 3 double bonds in it or 3 triple bonds in it somewhere in the big long molecule. That they won't ask you to name something like that. So if we're looking at this compound right here, here's the rule in terms of how to name these. First of all, the rule is that we just have to, when we do the numbering of the parent chain, we have to make sure that the double or the triple bond gets the lowest possible number. Okay, now this takes even priority over branches getting the lowest number. So if it's a choice between, okay, do I want this branch to get the lowest number or the double bond to get the lowest number? The double bond always, or the triple bond always gets the lowest number, no matter what. So if that means that the branches then have a higher number, then so be it, that's the way it is. So for this one right here, I'm gonna number this one backwards, so to speak. 1, 2, 3, 4, 5. And this double bond is touching carbon 2. It's also touching carbon 3, but 2 is a lower number, so we call this pent for 5 carbon, 5 carbon parent chain. And then we have to put a dash with a 2 in the middle to call it 2-ene. So pent-2-ene is the name of this compound. If I take a look at this one right here, you can see I've got a methyl branch and I've got a double bond. So again, I'm going to number this so that the double bond gets the lowest number. So I'm going to number this way. 1, 2, 3, 4, 5. I could number it the other way, but again, the double bond would have a much higher number, and that's not following the rules. The double bond must have the lowest number possible. So this double bond is touching carbon 1. So this is going to be, first of all, we have to name the branch. So the branch is 4-methyl, and then pent, because that's the parent chain, and the double bond is on carbon 1, so we say 1-ene, just like this. So 4-methyl pent 1-ene is the name of that compound. If I take a look at this one right here, alkynes, basically the same thing, except instead of ene telling me there's a double bond, I put ine to tell me that there's a triple bond. So this one would be pent 2-ine, and this one would be 4-methyl pent 1-ine. And so that's how you name compounds with the double bonds in them, guys. All the other rules apply. and compounds can kind of get a little crazy, as we've shown in some of the past videos. But if it's got a double or a triple bond in it, you have to make sure that the parent chain gets this name of ene or ine. If it's a ine, if it's a double, an alkene. If it's a triple, it's an alkyne. And then naming the branches the same as before. One sort of exception to this is when you wouldn't see a number in this case, and it's just for really short chains. And so the two examples for that is, for example, a 2-carbon chain or a 3-carbon chain, like this. And so this guy right here, there's no other place for the double bond to be, so we don't say that this is F1-ene, we just say it's ethene. And for this one, we would do the same if it was ethyne, so a triple bond would be here. For this one right here, this is prop, which is a 3-carbon chain, parent chain. And whether the triple bond is here or here, the numbering system is going to give that triple bond a 1. And so either way, it's going to be a 1, so we don't need to stick the 1 in simply because it's redundant. There's no other place for that triple bond to really be. It looks like there can be another place, but really this is just a molecule that's been flipped 180 degrees in 3 dimensions. So this would be propyne. So no numbers necessary for that. Once we get into carbon chains that are 4 long, so bute, then we do have but1-ene and but2-ene, and that matters because the double bond can be in 2 different spots with a different number, and so we have to put numbers in for those. Also, now moving on to this one, we have Cyclo Compounds. And again, the numbering system and the naming is basically the same. Follow the rules for naming these compounds, but the parent chain is a little bit different than a lot of these parent chains that we've covered so far. So these guys are in chains of carbons, straight, one here to one here, and there's 2 ends. For these guys, we've taken those 2 ends and we've connected them. So they're kind of in a circular sort of formation. And that's why we call them Cyclo Compounds. Now these guys here are called Cycloalkanes, and it's because they have only carbon-carbon single bonds. That means Cycloalkanes are saturated, and yes, they are aliphatic because they don't contain benzene. And so this guy's name right here is pentane again, but to distinguish it from the regular chain of pentane, which is just 5 carbons long, not connected at either end, this guy has to have a slightly different name. And so we call this, so the chain is 5 long and it's an alkane because they're all carbon-carbon single bonds. We just put cyclopentane or cyclo in the front of that. And so the name of this guy here is cyclopentane, and that's how you do those. All cyclo compounds are the same. If I've got branches here, then I would have methyl with the numbers and all the rest, and then the parent chain would be cyclopentane. If you put just pentane, then you're saying that it's just a straight chain of carbons, not in a circular formation. You can see this diagram right here distinguishes how it's related to the line diagram that we talked about in previous videos. And so this diagram here is the same as this one. Also this guy right here, Cycloalkenes. Alkene means that it's got a double bond in it. Cycloalkenes means that it's got a double bond in it and it's connected, sort of in this circular formation again. So you can see this diagram right here is my cycloalkene. This would be cyclopentene. Now the nice thing about cycloalkenes is that there's never going to be a number in the middle here like you see for regular alkenes and alkynes. And the reason why is because when I number this, I'm always going to number it so that I'm starting with the number 1 on that double or triple bond. And so the number there will always be 1, so I don't need to stick the 1 in. It's redundant to do that. We know how the numbering system works and the rules for that. Cycloalkynes, we just don't talk about those. They're really hard to make if they even are made at all. And so kind of for Chem 30, just say they don't exist, and we just we don't bother with those. There's no such thing as a cyclo compound with a triple bond in it. It's too hard, puts too much stress on the molecule, and it can't hold. So that's the naming rules for these guys. One last thing I want to point out is where these hydrogens are contained. And so if you take a look at this compound right here, remember that carbon always has to have a full octet, which means it's got to have 4 sticks or 4 bonds coming off of it. And so if I take a look at this compound here, I'm going to get rid of these numbers so that it's not so crowded. This carbon right here only has 1 stick on it. And so the rest of these are saturated with hydrogens. So let's write the hydrogens in kind of small just so that things will fit. This carbon's got 2 sticks coming off of it, so I've got 2 more sticks with 2 more hydrogens coming off. This carbon has 3 sticks already due to that double bond, and so then this guy only has 1 hydrogen there. If I stick another hydrogen on, that means that carbon's got 5 bonds coming off of it. It violates the octet rule. That doesn't happen. Same thing with this guy. He's only got 1 hydrogen, and this guy's got 3 again, due to only the 1 bond that's connected to it. And so through that, we can determine what hydrogens, or how many hydrogens are found on each of these molecules. If you take a look at this guy again, as well, he's got some hydrogens coming off as well. And so we've got those hydrogens there, that's a hydrogen coming off, that's got 3, that's got 3. And so you can count these up and you can see what their chemical formulas are. For these guys, same thing. I'll just put the lines in. That carbon's already got 4. That carbon's already got 4, so I don't stick any extra on there. And so I put hydrogens over there for that last one. So you can see the more double bonds and triple bonds that there are, the less hydrogens you would have room for, because those carbons would already be sharing electrons and filling their octets that way. This one's got 1, that's got 4, that needs 1, that one needs 1, that needs 3, and 3. So we can add these in. Now, if you want to kind of follow along with me here, take a look at these cyclos. These cyclos, you can see each carbon has 2 bonds in them. And so each carbon is only going to have 2 hydrogens coming off, kind of like this. And so I could write the hydrogens in for those. And normally for structural diagrams, you would do that. You wouldn't just put the lines in, you would write the hydrogens in for the structural diagrams as well as the condensed structural diagrams. Cycloalkenes, same thing. These guys have 2. This one's got 3 bonds, so that only has 1 coming off. And this has 3 bonds, so that only has 1 hydrogen coming off of it. And so you can see how this affects the chemical formulas. If I take a look at these, this compound right here is going to have a chemical formula of C5H10, if you're to count those out. This one right here, again, same thing, except it's got 6 carbons with this methyl branch. This would be C6H12 if you count all of those. This right here would be C5H8, and this one right here would be C6H10. Take a look at these cycloalkanes here. This would be C5H10, and this one, the cyclopentene, would be C5H8. Now what you can notice here is you can notice that the chemical formula of this alkene, if it's got 5 carbons, is the same chemical formula as this cycloalkane. And if you take a look at this alkyne right here, it's got the same chemical formula as this cycloalkene right here. And so the last thing that we can mention as it relates to the concept of isomers that we've learned in previous videos is that alkenes are isomers of cycloalkanes, and alkynes are isomers of cycloalkenes. And so these generic chemical formulas that we have for these are like this. Alkenes have CnH2n, and you can see that this one follows that rule, and so does this one. Alkynes have a chemical formula of CnH2 2n minus 2. And you can see these two follow that formula as well. Cycloalkanes, because they're isomers of alkenes, they're going to have the same generic chemical formula as well, CnH2n. Like that. And cycloalkenes are isomers of alkynes, so they would have the same generic chemical formula. And that's it. That's what you guys need to know. We've reviewed alkenes, alkynes, and cycloalkanes and alkenes in terms of how to name them, what the rule is, how to identify them, which ones are saturated, which ones are unsaturated. We've talked about also compounds that are aliphatic again, and all of these compounds would be considered aliphatic. And then we've also looked at where are the hydrogens found on each of these compounds, how do we put them in, and also we've looked at which compounds are isomers of one another. And so if you can review all of that stuff and you know all those things after you've watched this video maybe a couple of times, then you're good to go. If there's a gap somewhere in one of those things, then make sure that you go back, you watch the video again, and get the information that you need. Thanks for watching.